while. Big fan, huge supporter. My mom was a huge influence in my life. Single mom, grew up with her and watched her, in the IT world. So she was a communications major. So big microwave systems, landlines, did a little bit of programming here and there, but primarily communications background. Just brilliant woman. And she fought, pretty much her whole career trying to get equal pay and be treated the same level as, I would say, guys that were around who probably knew half of what she knew and half of what she could do. So, that being said, I'm a huge advocate and proud to be here tonight. So we're going to talk about distributed ledger technology, but before we do, I just kind of wanted to get a sense of, by show of hands, in the room, or is anybody familiar with distributed ledger technology or blockchain specifically? A little bit? Has anybody worked with it directly, coded anything? Genesis blocks, fun stuff like that? Okay. So, to kind of give you a little bit of background before we hop into this on myself, so I came from a communications background as well because of my mom. So that's where I started out. So I started building towers, huge network systems, pretty diverse background. I went from that to doing some automation work. So I would automate industrial and residential systems, anything from small scale all the way up to actually automating the Colorado Canal all the way out to the border. That was some of my first projects. Did a lot of military DoD contracts out of Colorado Springs. Did that for a while, so worked with NORAD, Schriever Air Force Base, you name it. So did that for a while. I was a bureaucrat, don't judge me, for a little bit. Bureau of Elections, so actually programmed elections, not my fault. I was an urban planner for a little while, but throughout all of that career, it's always been IT focused, programming focused, just huge projects, these massive projects all the way down to like really small projects. So that's a little bit about me. Also did some nonprofit work over the years as well. So what led to this? Well, about 15 years ago, I started a project on the side that was kind of primarily driven off of data. So it was GIS related and automated, automation, industrial automation related. And so looking at my background and a lot of people that I was working with at the time, we had very disparate networks, we had very disparate systems. There was all of these centralized systems that came into play, and just nothing really worked with each other, right? So you had all these different hardware and proprietary software and IDEs to do all of this stuff. And I thought, well, it kind of makes sense that wouldn't we just have a single solution for all of this instead of carrying around all this equipment, buying thousands of dollars worth of software. So I started down that path about 15 years ago, building I guess what you would call a peer-to-peer network, but it was a little bit more in depth than that. And so I kind of spun into a lot of other things over the years, and it got put on hold for probably 2 to 3 years. I took on a role up in Montana and North Dakota, and then I was offered a role down here, which is why I'm here now. And then that lasted for a couple of years, and then I met my awesome partner in crime, and I had a business idea, she had a business idea, and they were both really symbiotic, and so they could support each other. So her business idea was all around local food and designing and developing an application so people could find local food in their area and either pick it up or buy it or have it delivered, those types of things. I happen to have the logistics piece, which I was working on as well. So at the time, I was doing international and domestic sourcing, so I worked with a lot of different companies in regards to all the way from China to Israel, France, you name it. So we would source these products and bring them in. And so there was a lot of background for that to bring my logistics knowledge into that project. We decided to leave them as two separate companies just because of the structures and the focus. And then what ended up happening is we kind of started diving into, all of these problems that we're trying to solve. And we're like, okay, well, in order to really solve these problems, we need something that's going to be a little bit better for the long run. We can make it work now with traditional systems, but in the long run, in order for us to be competitive and stay focused on the edge of technology, we had to do something more, right? So even as a startup, we had to really push it. So that's whenever I brought my project of 15 years back into the fold. And I said, well, what if we just kind of rework this a little bit and we implement some new technology on top of that to kind of spin all of this up over a long period of time. And it kind of evolved into what we're working on now. I'll get into that. So that's where we're at. We've been to a few conferences. It's a crazy world to be in the world of DLT or blockchain right now. I swear, if you put blockchain on anything, it goes crazy, right? So, like Pizza Hut could put blockchain at the end of their name and they'll gain popularity overnight. So that's kind of a crazy thing to be a part of, but it's also really cool. It's a great community. But what really has got us here is all of those things that I just talked about, right? So all those disparate systems, things not talking to each other, so interoperability issues. But more importantly, centralized systems were created over the course of 60 years to facilitate some of these things that we're all familiar with, right? So ARPANET, the original internet, which by the way was never supposed to get off the ground, it took forever to get it approved, which was actually a peer-to-peer network by design, was decentralized at its base. It became centralized over the course of 60 years, and now we have what we know today as the internet. So we have client-server, we have these centralized systems that all of this stuff kind of works and facilitates our everyday actions, right, with technology. Well, if anybody can remember like Kazaa, Napster, all of those big peer-to-peer networks, right? So those were kind of the beginnings of what DLT is from the outside of commercial space. So those were individuals just wanting to get together and say, hey, let's create a peer-to-peer network, let's share some files, let's not be a centralized system like everybody else. Of course, there was a lot of problems with that, a lot of trust issues. It's like, well, do I really know if I'm getting this file from somebody, is it gonna wipe out my computer or my entire infrastructure and system? So, which is another core problem of centralized systems, right? So, one point of failure. So fast forward another decade or so, and now here we are, and we're talking about blockchain, which it's not really that new of a technology, but it is because of just a slight twist. So whenever Bitcoin, Satoshi, whenever he wrote that white paper about Bitcoin, there was a little bit of a twist that he did, and essentially took a peer-to-peer network, took some encryption and some fancy programming, right, and turned it into something that the world has never seen before. So now we have a distributed ledger technology to where we can all be removed off of a centralized system, and if I want to transact or have interactions, I don't need a central clearinghouse to do that. So now I can send stuff all the way across over to Europe, they can buy stuff from me, I can move things around, I can do all of these things because of that, and it almost becomes autonomous, right? Because we're removing that third party. It becomes a trustful system. And so we don't have to trust a bank, we don't have to trust an auditor, we don't have to trust somebody at a port or anything like that. So we're actually relying on the programming itself. So the blockchain itself is what people are buying into. That is the trust. It's immutable, it's global, you can't turn it off, right? So once it's out there, because it's peer-to-peer, it's decentralized, no single point of failure, there's a lot of benefits to it. So, what is it exactly? What's the definition? Apparently my screen resolution when I built it was different than this one. So it can be a lot of different things depending on who you talk to. It's still really new technology, and so things kind of get mixed up, right? So blockchain is actually a piece or a type of distributed ledger technology. Banks use DLTs all the time. They've been using it for years. Visa uses it. Any kind of credit card company that you can think of, they've been using distributed ledger technology for a long time. Now, if you talk to hardcore blockchain people or Bitcoin people, they would probably disagree with that. They would say, well, this is not blockchain, that was back then. It's essentially the same concept, right? And it's all about having a distributed ledger where everybody kind of has that same copy. So whenever I swipe my card and make a purchase, it goes through my bank, goes through the clearinghouse, goes through all of these systems to make sure I've got money, and it comes back and it clears it, right? And the purchase is made. But it's all these third parties. It's Visa, it's my bank, it's whoever they're doing business with, and so on and so forth, and all these networks. DLT kind of removes all of that, and it makes it direct. So now I can buy directly from the individual I want that product from, and they can receive my cash, and everybody knows that that transaction took place. And I can't also send the same money to somebody else, right? So it solves the double spend problem. And so consensus is one of the huge parts of what DLT is. So consensus, immutable, peer-to-peer, decentralized, all of these things are kind of the core of what makes blockchain and DLTs what they are. So as of today, probably the two biggest ones that everybody's heard of is Bitcoin and Ethereum. So Bitcoin was originally designed to just be a transactional currency, and it wasn't really designed to have a lot of business logic built into it, right? It's just like, hey, if you want to do a transaction, we can use Bitcoin, and we'll just move that around for all of our transactional purposes and value. Now, Ethereum came along, and the DAO, so Decentralized Autonomous Organization, came along, and what they did is they kind of created their own language. I don't know if you guys have heard of Solidity, so essentially everything in Ethereum, if you want to build on Ethereum, you have to do it in Solidity. You can do it in some other languages if you want, but that one's probably the most commonly used. And then if you get outside of those two, now it's kind of changing a little bit. The space is changing. IBM started a project. They've got all these huge corporations together to agree and to basically send all their developers and all their programmers, and they stuck them in a room, and they said, hey, what if we just start from scratch? Let's not do Bitcoin, let's not do Ethereum. What would that look like? And so all of these huge groups of people got together, and they came up with something called Hyperledger, which now has been handed over to the Linux Foundation, and it's open source-ish, in my opinion. I don't think it's totally open source, but there's a lot of groups that are working on it and kind of advancing that tech. So, core concepts, right? So Bitcoin is transactional, and then Ethereum came along, and we said, hey, we need some business logic. So then they developed their own programming language and said, here's some business logic to put on the blockchain. We still have transactional value, but anytime I want to write a smart contract is what they're called. So we'll build in that business logic into a smart contract, and it will only execute whenever the parameters are met. Right? So once all the I/O is good, then it'll actually execute, and you'll actually spend Ethereum to execute that contract. So you have to pay in Ethereum to the EVM, Ethereum virtual machine, to actually burn that contract, if you will, to execute it. And then, of course, everybody gets paid, or whatever the logic is in there, right? So that could include getting paid in Bitcoin or other cryptocurrencies, but the smart contract itself is in Ethereum. Now, some people are kind of advancing that, and they're stepping outside of it because there's some issues with scaling, especially with Bitcoin and also with Ethereum. And so Ripple came along, and they kind of developed their own consensus, their own protocol, if you will. And it's a little bit different. I don't know, there's a lot of controversy about whether Ripple's good or bad. You'll just have to decide that for yourself. And there's a few others out there too. They kind of come in different flavors, but really right now as it sits, if you look at the entire DLT space, all of it, right? The vast majority of it is built on two like consensus protocols right now, or two, I guess, blockchains, and that's going to be Ethereum and Bitcoin. There's some other ones that are coming out, and they're kind of starting to take hold, and people like them, and but there's this big question of like, okay, are these new ones going to have the same problems when we scale? Are they still going to be slow transactions, or is there going to be limitations to who can code it, who can program these in? Do you have to have an entire team just to create one smart contract? How does it work, at scale? So there's still a lot of questions. But I think everybody in DLT and blockchain space would agree that what we need is interoperability. We need to play with traditional systems. We need some infrastructure. And we need a lot more flexibility. And by the way, can we boost that transactional rate up significantly? Because right now, I think there's only, I'd say there's only one that's actually beating PayPal, but nobody's beating Visa right now as far as transaction rates. And keep in mind, you can do a lot more than just transactions, right? You can do a lot more than just singular business logic. So there's a lot of things that you can do with this technology. This is some examples of what that might be. Now, there's going to be people out there, I've heard some crazy ones that, they're like, oh, well, can I do a blockchain for my food truck? Like, you can, but should you, right? Why would you do that? And so it can be used at a very small level or small scale if you wanted to do that, but I don't know that it would actually make sense. I don't know that that's the right question, right? So it's like, can you use it for anything? Yes, but I think the real question is, if it doesn't make it 1,000 times better than what exists right now, then why would you do it? Right? So that's the question to ask if you want to implement this, or you're talking to a client or people that you're forming a group with and say, hey, let's create something. Just kind of ask that question. So there's a lot of projects out there right now that are all playing in these spaces. So that's everything from public, so just community-oriented open source projects, to very commercialized private projects. So there's a race right now in fintech, in the financial space. All of these banks, financial institutions that you can think of, they're building their own private blockchain, right? Because they want that back office, autonomous, like reduced cost for their business operations. Plus, they don't want to be outpaced by open source and something that, quite frankly, would eliminate the need for them to even exist. So it's definitely a battle. I would say it's almost getting to the point of a full-on war, but we're not quite there yet. Some of these groups are trying to play with each other. Some of them are not playing nice. There's a lot of misinformation from financial institutions, from Wall Street. All of these things are kind of the norm, right? So if you go back in time, it's the same thing anytime a general application tool set comes out. They did the same thing with the combustion engine, all the way through to the internet. All of these things are very controversial, but in the end, it's out there, it's growing, and it has an enormous global community behind it on all of these projects. So you may have heard of cryptocurrency, token, altcoin. Those are kind of like the three main terms out there. People kind of get them a little mixed up. Like I said, the terminology is still kind of nebulous while this is all kind of being worked out and developed. It's still really new. So a lot of times if you talk to a hardcore Bitcoiner, they will say, well, Bitcoin's the only true cryptocurrency out there and everything else is an altcoin. It's not exactly accurate. There's a lot of crypto projects out there that are strictly just transactional. Now, the interesting thing about all of this, right, is that every blockchain out there, they have this kind of asset that sits on top of it. So whether it's a currency or an altcoin, a utility coin, or whatever they want to call it, this coin, this asset is sitting on top of it. And now how that actually works with the blockchain is very simple. If you want to use that specific blockchain or the side chain of the main chain and so on and so forth, you have to spend or have or use that asset that's sitting on top of that blockchain, right? So if I want to use the Bitcoin network, I got to use Bitcoin. So I have to use Bitcoin to spend Bitcoin on the Bitcoin network. Same goes for Ethereum, same goes for all of them. So there's a lot of utility tokens out there that don't really fall outside of that. And it's kind of weird, right? Because we're seeing this like usage of this asset sitting on top of blockchains that's not really a cryptocurrency, but it's being traded and exchanged on these exchanges all over the world for value. And sometimes the value of these coins go skyrocket high overnight, just because of the scarcity of them and the dynamics and the economics of how they're set up. But the weird thing is the utility token itself. So take, for example, Ripple. Ripple is strictly just a utility token, right? But as soon as somebody buys Ripple, like I could buy Ripple, well, if I can go to a exchange platform out there, a cryptocurrency trading exchange platform, I can take my Ripple and I can trade it for other currencies, all these other cryptocurrencies that are out there. Even though it's still, at the end of the day, just a utility token. But for some reason, we're seeing all of these coins being thrown on these exchanges, and now all of a sudden, demand is going up and down and up and down. Right? So it's just like the Wall Street, it's the Wild West out there right now. So I would caution you to be very educated before you try to start trading any type of cryptocurrency assets.
Do you think eventually there'll just be one coin?
One coin to rule them all? I know, there's a lot of debate about that. Theoretically, I mean, I guess it would be potentially possible, but I don't really foresee that. I think it's gonna continue to be this huge emergence. We're just going to see more and more and more of these projects. I personally have kind of mixed feelings about it, but do we really need an application on the blockchain to buy tacos? I don't know. Maybe so. Maybe they're really good tacos. Maybe I need that to facilitate that. I don't know. But is it possible? Yeah. I think it's totally possible. I think if there was a singular solution that came out that had all of these capabilities, I would say that it's very possible that it might become more valuable or more used, more in circulation than all the other cryptocurrencies right now, if that makes sense. So this is a crazy little video. I don't know if anybody has seen this. Try to get it to work. So here's 4 years of ICOs. So does anybody in the room know what ICOs are? Initial coin offerings? Mm-hmm. Do you own crypto?
No.
No. Does anybody in the room own crypto? All right.
Am I the only one?
It looks like. So initial coin offerings are the crypto equivalent of IPOs, or initial public offerings, on Wall Street for stocks. Right? So because these assets have value, and they are essentially a security, I guess, that's what the SEC says. It's all up for debate right now.
So where do you fall on the securities versus utilities?
In the tech. Depends on the tech. So if it looks and smells and acts and plays like a security, then it's a security. But if it's strictly just a utility token, I don't see how that's possible. But this is a crazy world that we live in, so you can place value on anything. Mm-hmm. So if I have something that you want, even though it's not a security or a currency or anything else, it has a high value. Right? And if it's in limited supply, it's going to be even more expensive. So I always go back to the tech, but that's just my take. So here's the last 4 years of actual ICOs. So these are all individual products, and as you can see, you've got Europe, North America, and all the different places where these projects are kind of growing out of. So really slow growth over the last 4 years. Not exactly what you hear in the news about all this crypto stuff and these projects and decentralization. It's doom and gloom, and then depending on what group you hear, it's like, oh well, it's really exploding. Well, truth be told, that explosion didn't occur until mid-year last year, like Q3 over Q4. It just explodes, right, into this huge global project that everybody starts taking on. So after the DAO, everybody catches wind of what's really going on, what this tech's really about. But there's still a huge gap, right? So we're talking about some pretty advanced stuff here, and your average everyday user of tech is not going to even comprehend most of this. And so there's this huge disconnect, right? Of, well, what is it? How do I use it? What does it mean for me? How does it make my life better? So there really isn't this easy way to see it, to feel it, to understand it. If somebody gives you a dollar bill, you know exactly what to do with that dollar bill. If somebody hands you some stock, you know what to do with that stock. Most people right now, they have no clue what they're talking about whenever it comes to blockchain or cryptocurrency. There's just this huge educational gap, but also just understanding in general. How are we going to use it? If I don't play in this space as a programmer, as a developer, even support groups, IT groups, that type of stuff, if there's not education, it's not going anywhere, right? So no adoption, you're not going to win at the end of the day. So we have to have a lot of user adoption, and that's going to take a lot of work and a lot of education. I'm going to play it again. Just going to go to the next slide. That is not my font. Should have PDF'd it. So I want to get into actually what we're working on and what we've been working on. So this 15 years plus the other projects that we're working on, and kind of this convergence of technologies and solving these problems. So we've been looking at all of these different aspects of not just our businesses and what we're doing, but kind of the global. Okay, well, what's really going on? What are these problems that everybody's working on? And there's a lot of different companies out there working on different applications. So strictly just what I call Me Too applications. And then there's people that are actually working on infrastructure projects and trying to solve some of these core issues, right? So some of these big questions is, how do you get interoperability between each one of these blockchains? Well, I mean, they're kind of built on the same tech, right? So they're built on Bitcoin or Ethereum or possibly Ripple, or maybe they're stacked on top of each other. You start getting all of these layers, but no serious interoperability. So there's a few groups out there that are working on just that piece. Three or two. There's three that I know of that are working on just that piece alone. As well as like a lot of other things too, right? How do we solve the transaction problem? How do we solve smart contracts without needing to have a PhD in encryption and multiple code languages too? How do we solve consensus issues so we can do that? How do we say, okay, how do we validate an interaction online and not just a transaction? So just because I'm buying and selling and moving goods, that's one type of transaction, right? But what about everyday interactions? So how do I know if I send you a message that it actually got to you, and how do you know that it came from me if it's not coming from a centralized system, right? How do you trust that? Well, you got to put it on a blockchain. Because if it's on a blockchain, now it's immutable. We all agree that I made that interaction. I let you host, right? But we don't need a centralized system to do that anymore. So if we send a message, all these interactions that we're used to, blog, content creation, anything related to that can now be put on the blockchain without a centralized system. So those are kind of some of the challenges out there of, okay, well, how do we govern these types of systems? Who gets to make the choice? Does the system make the choice? Do we as a community, as developers, as programmers, do we build these things in so we can set it up right for the community to kind of govern themselves within this blockchain space, whichever one that they're playing in, or do we just allow it to grow and kind of, you know, metastasize over time into something different? So there's all these big questions out there, and sometimes it's a little scary for people. They don't want to have that conversation. But I think at the end of the day, some of the things that we're working on is looking at those big questions, right? Those big problems. And we're saying it doesn't make sense for, at least in my mind or in our mind, to have all of these core infrastructure pieces spread out between 25, 30, 40, 50, who knows how much more in the next 3 years. So it's like, okay, well, if I want to play on this blockchain, I have to write a piece of code so it can talk to this blockchain, so I can talk to this one, and so on and so forth. And every time I want to write a smart contract or put in some business logic, I'm going to have to write that every single time. Doesn't seem that scalable to me from a traditional business standpoint, right? Especially whenever you scale it up to international level and you start talking about international policies and all of these other things. It's like, well, we still have this huge education gap, right? Even the developer community and programming community, they're still getting up to speed on some of this stuff. So how are we going to have enough people to do this, or even better yet, how are we going to create a system in the future, or even now, that allows all of these things to happen right now? Because it is a race. Remember, big financial institutions, governments are issuing their own cryptocurrencies. This is a race. So in my mind, I'm thinking, okay, well, we can either allow centralized institutions to just assimilate this tech, and now they win and nobody really gets to use it, and it's just in the background. It increases their revenue and their margins, but it doesn't really help anybody, right? So this phenomenal technology just kind of goes away. Or as a global community, we can actually come together and say, look, this is something that the world needs, and not just here, but everywhere, for all kinds of different reasons. And it makes this, it makes sense to fight the good fight and to continue building and create.
Justin, you're at 30 minutes, just so you know.
Yep. So our solution overview kind of covers all of that stuff. And we'll have our white paper up on our website here pretty soon. I've been extremely busy on the back end doing a lot of work. So we're basically creating from the ground up a brand new internet, the internet that we were promised. Right? So whenever somebody first told me about the internet, they're like, oh, it's this thing, and you can go and check out anything, you can publish stuff. But it got turned into something of control. And we're creating the internet of the future. So that means an entirely new communications protocol from the ground up. Great part is it still plays with traditional IP stacks. So you don't have to have special hardware. You don't have to have special coding. You don't have to have anything, right? It's just faster because of the protocols that we're building into it. On top of that, we're kind of stacking communication protocols with blockchain protocols to create a decentralized system at the same time. So we're creating our own VPN, we're creating our own communication stack, we're creating our own private and public DLT, and we're also making it to where it will literally play with every blockchain and DLT system out there automatically from day one. So right out of the gate, we're solving a lot of the infrastructure problems. We're addressing the interoperability issues, and we're also solving the transactional issues as well. So I kind of already covered that. Oh, one big one that I want to hit. Inefficient mining and energy usage. So right now that is rampant. Right? So because we're trying to use these proof of work consensus protocols like Bitcoin, it takes a lot of computing power. I mean, I don't know if you guys have seen these pictures, but there's pictures of these mining farms throughout the country that are like literally tied directly into the grid. And I mean, this huge warehouses full of just nothing but these specialized, ant miners, and all they do is just sit there and mine, right? they're not solving any other problem except to win Bitcoin for that transaction. Say, hey, I won the race to guess the algorithm answer. So with our solution, that completely goes away. You no longer have to do that. It actually becomes quite the opposite over time. So it starts out at a low transactional value, and it really doesn't take a whole lot of CPU usage to do it in the first place. But the more people that use it, it becomes exponentially faster and more efficient, which is pretty cool, I thought.
So how do you do that?
Ooh, you have to sign an NDA.
Let's say, are you going to proof of stake, or is this?
I'll get into that really quick. I don't want to go over our time too much because I know there's a lot of questions. So I'll just hit some of the highlights. I've got a lot of slides here, and then I can get everybody a link to the white paper. So one of the coolest things I think that really helps define what we're doing is we're developing a brand new browser, if you will. I think it's better than that. I wouldn't even call it a browser. It's actually a 3D interface. So it has a heads-up display. You can actually literally see all of the information on the internet in a three-dimensional way. You can search it. You can theme it, right? So if you don't like the HUD, if you don't like the planets, you can theme it later on down the road. So we're developing that. But the big point here is that instead of just going to a singular website and having no clue or concept as an individual user of where my data is going, where it's being stored, who I'm interacting with, what systems are coming into play on that website, and not really knowing, you'll actually be able to see this here. So you'll still be able to navigate to websites if you want, but you'll actually be able to see where that data is going. And you'll have complete control over your own personal data, by the way. So nobody can take your data or your information regardless of their terms and conditions. So everything that goes from our application off of any device has to go out with your permission, which means you can also get paid and monetize your own data, right? So these big corporations, they're taking your data right now and they're selling them off. All of that data is being sold off in billions of dollars. I mean, the big data race is on, right? Whoever has the most data wins. This solves that. It takes that power back to where it belongs, and that's the individual. So just kind of some more concepts of what we're actually doing. So essentially, a star is kind of your core DLT technology. So we could have thousands or millions of stars eventually in the RevoVerse. And then off of that, you'll have planets and satellites. Singularities are what we call individuals. And so they all kind of like work together. And so you can kind of see like around a single star, you could essentially have thousands of planets around a single star, right? So those single planets could be individual applications. You could have something that's being built off of that core tech, the core DLT. You can also have these satellites, right, which satellites can still access the centralized star, if you will, the core DLT, or they can access the planet itself. But this is really more for just mapping it out and to understand spatially how these things are working together. And so we're creating this wireframe, but it's actually based on artificial intelligence mapping. So all of our communication protocols run via AI. So how data gets routed, and then also how the data is actually viewed is all wrapped around AI geospatial. So we're taking this entire gaming environment, right? That's the easiest way to kind of think about it. So we're creating this entire environment visually, and we're saying, okay, well, how do we actually map where something is at? So we take a core technology and say, that's a star. Anything that comes off of that, right, is applications or secondary usage. And that now allows us to not only get the data where it needs to go faster, but it allows users to find that data more efficiently and effectively through a 3D interface. So this is RevoNet. So these are all of the kind of, I guess, stages of what make it what it is. So all the way from the user using the Revo app to our physical connection and all the way through. So essentially once a user is connected to the RevoNet using the Revo app, then they can actually have complete privacy. So ISPs can't tell you what you can and can't see. Google can't tell you what you're only allowed to view in your search results. So you're not limited anymore. So you can literally search the entire RevoVerse for anything and everything that you want. You can also limit it, right? So you can filter out things that you don't want. But the point is that you get the choice back. Right? So you have control over your information, your data, and you also have control of what you can and can't see, what you want to interact with. And the great part is that now you actually have a physical way of visually seeing how you're interacting, not just with blockchain, but with all systems whenever you're immersed in your online experience. Here's some really fun protocol stuff. I won't go through each one of these, but essentially at each level of our stack, we've kind of created our own protocols that kind of work together. So this is the combined protocols and technology at a very core communication layer that allows everything to function and work the way that it does at the end of the day. Revo-Fi is something I'm really excited about. You will actually be able to share your Wi-Fi connection and also be able to be connected to multiple Wi-Fi connections simultaneously. And you'll also be able to manage your Wi-Fi connected devices at the same time. You can actually sell your bandwidth while you're not using it. So what that means is my phone sitting here right now, I could actually be selling my unused bandwidth to anyone in this room and making money, even though I have no clue who's using it. So I can allocate how much bandwidth I want to use myself, or how much I want to give up to anybody else, or I can just set it to auto. But the great thing is that now I don't need an ISP anymore as a user. I just need to be able to be around somebody that has Revo-Fi. So if I can't afford, to pay for a data connection or anything like that, and because they are getting expensive, and at the end of the day, they kind of own our devices, right? So this takes that and it puts it back in the individual's hands to where, why not share it? If I'm not using it, why not make money, right? I can literally pay my entire data bill just by sharing my bandwidth, my unused bandwidth. It also allows for interconnectivity in the verse, and it also speeds it up and creates what we call swarms, which is what your question was, is what kind of consensus protocol. So the verse fabric, here's kind of the core. So once you're actually in the RevoVerse, here's all of the core things that are actually making that tech work. So we have what's called the AI autonomous interface, which is also a really cool thing that we've been able to work into the system. And what that means is that now you can take any AI system that's out there, any AI engine that you can think of, and once you connect it to the RevoVerse, they can now start interacting together if you want it to. So if I own an AI engine, and let's say you own an AI engine, and you do, well, I only need some of your data to help speed up the process to train my AI. So I can buy that data from you, and maybe the result of that is what your AI engine needs, right? And so now we can make all of that happen. So rather than having these siloed AI engines out there that only Google gets to use, or only one company gets to use, or anything like that, now we can actually spread it out. And more importantly, we have the connectivity between those AI engines so they can actually learn from each other faster. Right? So it's not just about deep learning, it's actually a step further than deep learning. What we're actually talking about is the ability to take the wisdom of that AI all in one chunk and pass it off to another AI engine almost instantaneously, as fast as that connection and the computing power can handle it. So literally, I can train my AI from your AI for just what I need in a matter of hours, rather than what used to take months or even years. And so we've streamlined it by really cutting out all of these, what I call bloated algorithms, and we're just going to streamline that process. So really excited about that, and I think that's got some enormous potential. Swarms, I'll get into that in just a second. Or now. So swarms, right? If you can imagine, if everybody in this room was connected to Revo-Fi, or even if they were just connected to the RevoVerse, swarms are how we actually do our consensus for our blockchains. So if we're all connected and everything is artificially intelligent for our data routing and our mapping, what ends up happening is we all kind of start becoming interconnected, right? And so now, if I want to have a transaction with somebody, so rather than it going out to the entire blockchain community and all of them are putting this tremendous amount of like computing power to solve and compete for that solution so they can get rewarded in Bitcoin or Ethereum or whatever these other cryptocurrencies are, what we're actually doing is we're scaling it way down. We're developing on speed, right? So these consensus algorithms are built for speed. So rather than these slow, bloated, lots of computing power, what we're actually doing is we're splitting it up. We're taking a very small piece, we're compressing it, encrypting it, and we're sending it out in a very specific way through our intelligent routing system, so then that way we can come up with consensus between singularities. How does it work? Okay. So we also have what's called an identification system that's built into the platform. So it knows who you are, and it is the only one that knows who you are. I will only know who you are if you share that with me and if you decide to do that. So at the end of the day, if I wanted to make a transaction, right, here's our singularities transacting down here. So they see that transaction, they actually send it up to the RevoVerse AI. That RevoVerse AI is something that's also new, that nobody else has done. So rather than have the entire blockchain community, right, work on this, we're actually taking that entire load and putting it into an artificial intelligence system, one engine. And its sole purpose in life is to just process and verify those transactions. That's it. So it does a few things. So it'll take that transaction whenever that occurs, sends it up to the AI, says, okay, I see it, sends it back out. Now, the whole global community on the RevoVerse is connected, right? Except for this. So whenever there's an actual transaction, it'll actually split out your own individual swarm. So randomly generated, you'll never know how many people are in your swarm at any given time, and it constantly fluctuates. So what happens is you get that piece back, that hash, if you will, from the RevoVerse AI. Each one does. They send that automatically, broadcast it out to your peer-to-peer network swarm. And once the swarm actually synchronizes, that swarm synchronization, then it'll actually send it back out to the RevoVerse AI. The RevoVerse AI will actually validate that transaction and then write the new block. So right now, you're probably looking about 1 million transactions or interactions per second based on current hardware specs, current network specs. These things are going to improve over time. Right? So as we get better infrastructure like fiber everywhere, CPUs are getting faster, GPUs are getting faster. So we're the only ones that I'm aware of right now that are even doing anything remotely close to this. This is something that's completely new. Now there's some tech out there that's kind of in the realm of this, and it is a lot faster, but I think they're somewhere in the vicinity of 60,000 transactions per second. So not quite as good, but they'll probably get better. And that's it. I know I went over a little bit, so just wanted to tell you guys thank you once again for having me, and yeah, stay passionate, get involved. So. Time for questions, or do you guys want to? Okay. Anybody have questions?
What's your exit strategy? Do you have one?
my exit strategy would
Sorry,
be.
you get kind of businessy.
Perhaps
Yeah.
it's okay.
I would say that the exit strategy is that once there's a high enough adoption, we'll probably open source a lot of this. Yep. So that will be kind of the end game. I don't know that it'll be everything, but I think the vast majority of it will eventually become open sourced.
So in that case, what is your adoption strategy? And you mentioned having a white paper. Are you guys doing an ICO?
So unfortunately, I can't talk about anything on the fundraising side
Okay.
legally just yet. But I can tell you that we will be going through fundraising very soon. Yes.
Well, and just to add to that, as far as adoption goes, there'll be some of the other projects that we're working on, like RevoGrow, which is the local food marketplace that we have, which is currently a business that's running right now, will be applications within the new infrastructure. So those will be like revenue generating, and also users, like all of the people that use our current platform, RevoGrow, like farmers, ranchers, restaurants, will be using this new system whether they're necessarily aware of it or not. Is that correct?
Yeah, and it's really going to be a choice, right? So it'll be on the system, but I would say the biggest strategy for high adoption is low friction, make it easy, make it simple. So visually, our interface is better than anything else out there that I'm aware of. It gives you a visual way, a natural way to understand what you're interacting with. Then I would also say that we've built in what's called dynamic smart contracts, which essentially means that you don't have to have a programming background anymore. We'll have pre-generated libraries for different business verticals, so or any kind of like market that you can think of. And essentially just simple drop downs, you'll be able to create your own smart contract on the fly. Super easy, right? So you don't have to have a huge programming team to create a smart contract every single time. Now, it does split off, so you can do your own development if you want to do that. So that's the great part too, is that it also works with custom, and it also works with traditional, and it also works with other tech. And so there's this whole interoperability play, and I think that all combined is what's going to give us our mass adoption.
So is it language agnostic then in terms of actual spoken languages?
Spoken languages?
Yeah. So if someone's going to program in this and understand it, you know, if they're in Japan, Korea, how easy is it going to be for them to learn the information to program these smart contracts?
Well, the great part is that it's all built in C and C++, the core.
Okay.
So you can pretty much build anything on top of that. So any higher level language that you can think of, PHP, you can build whatever you want on top of it. But as long as you can code in C and C++, you're solid.
Wonderful.